change things to see how it changes the visualization. It seems to be working now, but I'm not 100% sure if the implementation that I have there is the same that I had before. So it's gonna be hard to know for sure, so I'm just gonna step over the code and see the values and then maybe change things to see if how it changes the simulation. Then after I do that, I still have to add the two other solvers, which is the spring solver and the central gravity solver, which are just simple calculations, but I'm going to divide the main function into 3 functions probably. I'm gonna do it the same way that I did on the other project, because probably later I'm going to put other stuff, layouts and stuff like that. So there is one problem that I'm getting, which is this function here. So every time that you update the positions, you have to re-update the minimum and maximum for the geometry, because I'm doing the calculation each time, which is the exact way that I was doing on the other one, I think. So every time on every frame, you have to recreate the tree, and then you have to calculate the forces after you recreate the tree because the positions change. So I think that this is probably the easiest way to do it, but it's probably better. There are probably better ways, and this is partially what I'm thinking about now as well, because, well, there's two different things. One is if you could create and update the forces at the same time, it would be obviously better, I think. And the other thing is if you can create the tree only once for the entire duration of the thing, and then just updates the tree based on the position, then obviously it's better as well. And especially because of the memory, because the way that I'm doing this now, the tree is a object and it's going to be part of the, I have to allocate memory for each node of the tree. And then I was deleting here, I created a function to delete the memory each iteration. And now I'm testing without deleting. I'm not really sure if I ran after compiling without deleting the nodes every frame. But it's probably better to delete, but then it sounds really bad, I think, because you're creating a nodes each time on each frame and then deleting the nodes. So it obviously, it sounds better if you only create the nodes once and then you just rearrange, but it might be extremely annoying to rearrange the nodes or to update the tree. So I'm not sure if it's worth it to think about, to spend a bunch of time thinking about this, or just trying to implement, because this way is the exact way that I was implementing on the other parts there, but the other parts obviously on JavaScript, so you don't have to allocate memory. And it seems for whatever reason that is not working to update the minimum maximum vertices for the geometry. Still gives the error. So I'm not really sure, because it is also, it feels that it's probably incorrect, the calculation, but I'm not really sure it could be correct, because they just deviate like forever. They never stop, so there's probably something wrong here. And this message here is the error message that I put there for the circumstance where the position you're trying to calculate is outside of the boundaries of the geometry. I'm not 100% sure if that's if the way that I built that is correct, but if it is, then that's what's happening. It's not updating the vertices correctly. So I'm just gonna step over. I gotta open on the VS Code. Let's just step over. Barnstadt's solver. So it basically, I'm gonna step over each thing there. Then as I step over, I'm gonna explain how it works. But it's basically just calculation of mass, a gravitational force. It's a. I'm not sure if solver is the right way to put it. It's more like an algorithm or an approach, a way to calculate gravitational force on a body or on a geometry, whatever you want to say. It's also taking a very long time, even off string when I was doing this. I think on some situations, because I tested it, initially it wasn't correct, so it was giving dangling pointer thing, I think. So it was just breaking the stuff. And then I went over with the debugger and then I changed some stuff because it was problems with the way that I did there. And because I tested a couple of ways, sometimes I think it took a lot longer to open. But I'm not really sure if it is a problem, because I think maybe it's not a problem, it's just the way that it always is. Probably the best thing to do is to implement everything first. So there's one main thing that I think it might be wrong, which is the initial node. So, and obviously the nature of the tree is different in the way that I did there. But I'm not really sure if I put the condition as well to prevent the, because in my mind, like, to put the condition to prevent the node from exerting force on itself, because obviously you create the tree once and then you use all the nodes on the graph to put on the tree. So they're going to shape the tree. And then based on that, when you're calculating the forces, you're going to use the same nodes that you use to create the tree. So you're going to calculate the force that the node exerts on itself. But I thought that this is probably not that big of a deal because the position is going to be pretty much the same. So if the position is the same, then I think it's going to be 0 or very close to 0. But so it shouldn't affect the force very much, even if it is wrong. And then all I have to do is put a condition there to prevent the node from obtaining force against itself, like exerting force against itself. But I think that it might be wrong. There's two things. One is the way that I did the calculation there, because I did it based on the center of mass of the current node, because I'm assuming that the way that I did the center of mass of the current node is going to be the position of the node itself. But I'm not 100% sure. And the other one is the first node, because the first node is going to exert. But I think it's fine. That's the best way to do, just to step over. So basically, the way that it works here is that I'm passing all the nodes on the graph here, and then the minimum vertex is supposed to be it's supposed to be the vertex that represents the edge of the entire graph. So whatever node is at the bottom left and back of a cube on 3 dimensions, and the maximum would be the top right on the front of the cube. So the minimum and maximum vertex creates the diagonals of a cube in three-dimensional space that encapsulates geometry, which in this case is a node. And the AMBB class on Godot is an axis-aligned bounding box. So it is the class that creates the box based on the size, which is the maximum vertex minus the minimum vertex, because this creates the vector of the diagonal of the cube in three-dimensional space. So so the A and B takes the size and the minimum vertex in order to simplify the amount of stuff you need to create a cube. So I'm basically creating a cube here, and then I'm using the cube to initialize a node in a tree. And the purpose of the tree is going to be to split the space based on the nodes of the graph. So you're splitting the space, the cube, into other cubes based on the position of each node. And that creates the tree data structure that allows you to simplify calculations of forces in the bodies of the graph. And that's basically the purpose of the thing. So the way that it works is that you're going to have a theta parameter, or you can have any parameter you want, and then based on the parameter, it serves as a threshold of simplification of the search space that you do to calculate the force on each node. So like the brute force solution would be to you do a nested for loop. So for each node on the graph, you calculate the forces that all the other nodes exert on that node. So it's like a nested for loop, because the outer loop is going from all the nodes, and then the inner loop calculates the force of all the nodes on that node. So the tree data structure allows you to simplify based on a criteria or heuristic, whether or not you need to calculate the force against all the nodes, or you do a simplification like in the Barnsat case is going to be taking the center of mass of the nodes and the overall mass of the nodes have as a body. So instead of going over all the nodes, you can simplify based on whatever criteria. So it's like you're simplifying the search space or minimizing the search space by doing approximations based on whatever you want. And then there's, I think, like the standard way to do it is on 4 dimensions, you're gonna have a tree that has 4 children, because you're dividing a square into 4 parts each time. And in 3-dimensional space, you have a tree that has 8 children at each level, because you're dividing a box into 8 smaller boxes on each iteration. I think that's one way to do it. But the way that I'm trying to do here is I'm using a binary tree. And I think that there is always this relationship between the amounts of children that each level is going to have and the structure of the spaces that you are splitting each time. So if you have a binary tree, then obviously at each level of the iteration, every time you add a node, you're going to divide the space in half. But and this is another nuance, because in the way that I'm doing here, this could be another part that is wrong, but I'm not 100% sure. Like I'm not trying to divide the space in half each time. I'm trying to divide based on the positions of the 2 different nodes that I'm adding. So the subspaces that the main space creates are not always the same. And I think on the standard implementation, they're all supposed to be the same. So you would always divide in half, for example, and then you do a recursive iteration every time you're going to add a node. And if they're still on the same space after the first division, then you divide the space again and again and again until you get to a situation where the space only contains 1 node or 0. And yeah, that's the nature of the tree. So the external nodes are always going to have either no spaces, no nodes or 1 node. And all the other nodes are going to be subspaces. So like the tree represents the structure of the space you are converting. And this allows you to do the simplifications by traversing the tree to apply the force and implementing heuristics if you want to simplify the amount of time, to reduce the amount of time by using simplifications on the force. So this is a function that I created to add nodes to the tree, which I'm not 100% sure if it is correct or not. But the new body is the nodes of the graph, and the current node in the beginning is going to be the root of the tree. So yeah, so it puts two situations here. The first one is when the node is a space. So I have this flag variable isBody that indicates that whether or not the node is a body. So the first situation, the roots, obviously the tree doesn't have anything, so the root is going to be a space. And by default, the nodes don't have children. So it's going to fall into this condition here, which means that I'm going to turn this node into a body. So because I'm adding the first node to the tree. So the root's going to go from space to body. So I'm just changing the states of the current node. And then I return. Then the next one, I'm trying to add a node to the root, and the root now is a body, so it goes to this condition. And here I did this calculation to make sure, because I'm not 100% sure in the way that I did the subdivision of spaces, because I got from ChatGPT, so I'm not 100% sure if it's accurate. But I was imagining a situation where I have bodies on the same position. So if that's the case, then obviously you can't divide the space into different planes, because it doesn't matter how many times you divide, they're going to be on the same position. So in order to avoid that, I'm just shifting the position in case the node being added has the same position of the node that was already added to the tree. I just shift one of them a little bit to the right, or to this direction here, to this vector. And yeah, that makes sure that I'm able to divide them into different spaces. Then this is the function that I'm not sure, which is the function that, because this is a body, and you can't have two bodies on the same node, you have to subdivide the space. So this is the function that I'm using to do that. So I'm passing the new body position to this function. And then what this function is supposed to do is to get the position that already exists on this node, which was the previous body added, and the new position that I'm trying to add. And then it's going to create two different subspaces based on the first space that the node already has, which is the node space, which was the space that I used on the beginning, which is basically the box that encapsulates the entire geometry based on the minimum and maximum vertices of the geometry. This I could probably just get from the A and B, because they had a function here to get the center, I think. Yeah, we got center. Position plus half the size. So just taking, just splitting along the whatever axis it chooses here. So it gets the largest axis based on this, and then based on whatever is the largest axis, it's just gonna take the position. It's gonna take the size in the center of that axis. But this is not. I'm gonna have to change this function, so I'm gonna have to think about this. Because it isn't what I was thinking about. So it looks like it's just dividing the box in the middle based on whatever is the largest axis of the box. But I was thinking about making sure that the two, because the two nodes, so it's basically just comparing not the node, but the position of the node. So the two nodes are going to be on the same space initially because the space encapsulates the entire geometry. So what I was thinking about is that I can make, and this is where I think there's a lot of nuance that goes into play, because there's an infinite amount of ways to split the space based on the two different nodes. And I think that the division is going to depend obviously on the position of the nodes. And not only on the position of the two nodes you're comparing, but the position of all the nodes in the entire geometry, because it's going to shape how you do the traversal of the tree later, so the search of the space. And I think that like the structure of the tree is going to determine how fast or slow the calculation is going to be, depending what kind of calculation you want to do and what is the relative position of all the nodes. So I think that like if you always split on the same way, then it's probably not very good. But it might be the easiest way to do it. Because then, yeah, but maybe it is the best way. I'm not really sure though. Like basically the density of the geometry you have is gonna determine the relationship between how these spaces are broken down. And but it's very hard to think about what does that mean. Here, I think what is happening is just getting the longest axis of the positions, and then it's just subdividing or cutting the axis in half, basically, based on the center, and then creating two different boxes based on the half of the largest. So here, in this case, is dividing by the x-axis. Just creating two boxes on the half axis. I'm trying to think about this because obviously you have like one situation would be you have a very sparse geometry, so all the nodes are evenly spaced on the first original space, and then you have the other extreme which would be that the geometry is very concentrated at one spot of the space, let's say. So like you might have one node that is very outside and all the other nodes are on this roughly on the same place. Then obviously it makes sense that the separation of spaces on two different cases, there's probably going to be a relationship of which one gives the tree that is the best to do the calculation. But I'm not really sure like what is the relationship. That's the thing that's kind of, I'm not even sure if you always split it the same, if it is going to be worse. Because after the first division, you would have pretty much the same situation, I think. Oh no, it is doing based on the maximum. So maybe I misunderstood this. Also, it gets the longest axis based on the current space, but then it does the splitting based on the two positions. So maybe it is correct. So this is the position of the first body, this is the position of the... So it's like creating minimum and maximum based on the two different bodies you have there. And then it's getting the coordinates of the position here, comparing the coordinates. And then swaps the minimum with the maximum. So it's just swapping so that it makes sure that... Oh, but this is... It can be problematic, I think. Or maybe not, actually. Yeah, I think it's not problematic. It's creating two different variables to store the positions of the two bodies. And then you're swapping them in case the maximum is smaller than the minimum. But it's basically the same thing. And it calculates the center based... Oh, yeah, I'm missing. So it is correct, yeah. So it's confusing this minimum and maximum of the node space. No, actually, maybe it doesn't make sense. And maybe this part here is the one that has to change. Because it should be this shoe, I think. So it would make sense if the center is the center between the two different points. So if here was minimum and maximum position here, then what would mean is that is getting the center between the two different points, and then is splitting the space in the center of the two different points. But I think that's not what's happening here. Oh, the thing is, there is a limited amount. I'm not really sure though. It is infinite technically because you can always go smaller. But I think that the angle is limited because obviously, depending on the way that you split the space, you're going to create a different geometry than a cube, than an axis aligned bounding box. So I think the orientation, the angles are limited, but the range is infinite probably, because you can always get more specific. Hey, what's up? But here I'm not really sure, because using this minimum here, and this minimum and maximum is from the node, from the main space. But maybe A and B true. Oh no, the A and B true is based on the max. No, but it is the same thing. Yeah, it doesn't make sense. So what I'm gonna do is just change. I'm gonna see if it changes if I do minimum position and maximum position here. Yeah, I think that the way. So I'm gonna test like this next time, but I'm continue. Because it can also be the calculation of the center of mass or something like that. That is the problem. But I think that the way that it is there is probably not correct. Because just subdividing the space based on the previous space. So it's like I was dividing in half, I think. Which is not what I wanted. But if I do based on minimum and maximum position of the two different nodes, so I compare the position of the two different nodes, you get the middle point between them, and then you divide the space from that middle points. That makes sure that the subdivision always happens in a way that the two different nodes are on different spaces. Yeah, so this, after you subdivide the space, you're gonna check to see in which one of the spaces the body that was this node here is gonna go. So this node was previously a body, which is the first node that I inserted on the tree. So the first node in the graph that gets inserted becomes a body. So this is the second iteration where the root's gonna be subdivided into two different ones. And the way that I am doing here, which is I think is different than the way that usually is done, I'm just passing the nodes right away to the next level of the tree instead of calling the function recursively. I think usually you call the function recursively, and then you call for both of them, and then you have a way to prevent an infinite loop on the recursion by putting some heuristic inside of the function that prevents the nodes from always falling into the same space. Because obviously, if the node fitted on this space here, the next time that you call the function recursively is you would just be going into the same space each time and then causing the subdivision forever. So if you do the recursive approach, I think you need to have a heuristic that is going to prevent nodes from being added into the same space that they were previously added to. So that way you're always passing the subdivision down the tree for both nodes until you get to a situation where they are on separate corners of the space. This is weird. I'm not really sure if I skip this. Or if I did the calculation. Let me. Oh, so it's because so this is false because I changed there, so you added a line, so the step over now is on the wrong line. So I'm probably gonna stop this and then compile and run the debugger again. But here I'm basically just updating the state of the subspace based on. So in this situation is the body that was at this spot here is going to go on the subspace 1. So I'm updating the subspace 1 to become a body, and then I'm just basically updating the value of the total mass and central mass based on the values of this current body here. Because the node stores the graph node that was added to it. I actually split into two different files as well, because I was having a problem with multiple definitions. after I changed some stuff, because one of the problems I think was because I wasn't registering the class on the class DB, so the editor was crashing even though the code was working. And that's the first problem that I had, and because I had to change this, I had to put this on a C++ file so they don't have multiple definitions. But yeah, since I know that the node that was here is going to go in subspace 1, then I can add the new node into the subspace 0. That's basically what I'm doing. So I'm updating both of them. And then I update the center of mass. And this function, I'm not really sure if it's correct, but it seems that it is correct. So so each time that you add a new node to a subspace, you need to increase its center of mass and total mass, because each node is going to hold the state of is either going to hold the state of the body that was added to the node, because now the node is a body, so it's going to have its mass and its position. But I'm always going to use total mass based on the way that I'm doing here. I'm always going to use total mass and center of mass. But in the case where the node is a body, then the center of mass and total mass is just the position and mass of the node. But if you have a node that is a space or a subspace, then the total mass and center of mass of that node is gonna be the center of mass of the entire all the nodes, all the bodies that are children of that node, and the total mass is gonna be the mass of all the bodies. So the state of the node is basically contains a simplification of all the children that it has. So every time you add a new node as a child of a space, you need to call this function. I'm not 100% sure if it is correct, but I think it is. So I'm just adding the mass. I'm just adding the new mass to the current total mass of the node. So if it is 0, I just change so that I don't have division by 0. And then here, just multiplying the current total mass by the center of mass, and then adding the new mass. So just a weighted average of all the masses multiplied by their position divided by the total mass, the center of mass, and then I just update the values. So just add the calculation of the new node into this one. And then I change or maybe this one is incorrect. Oh, no, this is correct, because I'm changing the state of this node here, which was a body, should be a subspace. So I'm just making the body null pointer and setting to false, the thing there. And the thing is, I only have 2 nodes on this one, so I might add the other one, but first, so I'm going to stop here, I think. Let me go over, because now it's going to be a problem. So I think I'm just going to stop, and then next time I'm just going to skip this function here. And because the main one that I'm not 100% sure if it is correct is this calculate by the force, because I'm not sure. So the first thing that I'm going to try is just change the theta parameters, because the theta is the main thing that I'm doing differently than the other project, I think. Because on the other one, it does calculation that I'm not 100% sure. So here's basically the same thing. For each frame, you create the tree, and then insert the bodies on the tree, and then you update the force using the tree. So updating the force is just passing the tree through the entire, passing the node you want to compute the force through the entire tree. And then based on the threshold, you decide whether or not you apply the force or keep traversing the tree until either you meet the threshold or you get to a node that is a body. So the threshold is a part that I'm not sure, because it's the parts I'm doing the threshold, it's called theta, and I'm doing based on the size of the cube and not the width, I think, because they say that you have to do the width of the region divided by the distance between the node and the other node's center of mass. But the calculation here is kind of strange. So this is the function that that I was using, which comes from another code. And this is basically the calculation. So this is how they are checking. So yeah, one thing that I didn't like here that I should change probably, but I'm not gonna do anything with this code anymore probably, so I'm just gonna leave it like this. But it's kind of confusing because ours is actually the distance here. And this is another thing that I was originally gonna do. Just use the function that they have on the vector tree to calculate the distance, stuff like that. But it seems that you have to split the calculations into 3 different parts because they have to be applied separately on the stuff. But I'm not really sure if that's the case. But I just didn't want to spend a bunch of time thinking about this, so just decided to do it the same way that they are doing here. So here, they make this equal to 0 in the beginning, and then for each iteration that the node is traversing the tree, you're just updating the overall force. Based on the velocity, which is the calculation, this gravity is a value you put on the parameters there, and then multiplying this constant with the 2 different masses. So the mass of the body you're adding and the mass of the, or maybe it's the other way around, I don't remember really well. Because here at the end is gonna, so the source body is the one that is being computed. And then the body is the one that exists on the tree already. So you're just multiplying the mass of the current node. This case is if the node is a body. So it's not a subspace, it's just a body. So it's going to be its mass multiplied by the mass of the other node and divided by the distance to the power of 3. And the distance is calculating based on the delta of each position, which is just the difference between the position on that direction of the 2 different bodies. And then you multiply the velocity by the distance and you add that to the force. So each node you're doing this. So if it's not a body, then what you're gonna do is gonna consider the node's gonna be a subspace, and this subspace is just the simplification of all the nodes that are children of the current node that have their center of mass and total mass. And this calculation I'm not 100% sure because this is the one that I'm doing differently there. But here, because on the other one, I think I'm doing all the axes at the same time because I'm using the size of the A and B. So the ratio SR, where S is the width of the region represented by the internal node. And this is the part that I'm not 100% sure. Like, what does it mean by the region? And R is the distance between the body and the node's center of mass. So here, I think it is just getting the mass at that point. So like the proportion of mass on each direction based on the overall mass, and then subtracts the direction. So I think it's just based on the body is getting its, yeah, it's getting, like this gets the center of mass on here, I think. And the distance is R. Then it does this check here based on the theta. Theta comes from the parameter that you put. And I think that on the standard way to apply, it goes from 0 to 1. But I'm not 100% sure. By default there, I know is 0.5. So here is dividing the right. And this is the part that I'm not really sure because I don't remember what right and left stands for. Because I think that this tree here on this example has more than, it has 8 children each step. So I don't remember what right and left are here. Treat this internal node as a single body and calculate the force it exerts on source body. And add these amounts to source body's net force. So if the theta was reached, then it means you're going to simplify the calculation. So you're not going to calculate through all the nodes again. You're just going to calculate the force here. Considering that this node is the actual node and not all its children. So it's just basically the same calculation, but the mass here is going to be the total mass of all the nodes, I think. And the dx is probably central mass. Yeah. So it's multiplying the central mass of the space with its total mass, which is a simplification based on theta. And then you update the force like that. And if the threshold wasn't met, then you're supposed to call the function recursively, but here they use a queue. So I think they're just doing breadth first search here, I think. So just continuing the traversal of the tree until you reach the point where you have a body or theta. And then in the end, you just apply the overall force that the whole tree had on each node on its force. So it's changing the state of the thing there, or the node. So let me see if I can, some nodes. Yeah, right. Oh, so it looks like it's just getting the... so this is the part I'm going to see. So I think that is different because it looks like the width of the region is just the width of the box you get. And because I'm doing based on the size, I'm getting the diagonal and not the side. So either I change that. I'm going to stop here. I'm going to compile again. And I'm going to go over again. But I'm going to see, because there is a function there that's going to allow me to see if it makes sense to do what I'm doing, because I'm pretty sure that one of the functions they build the entire vertices for the box based on the size. So the only difference is that you're increasing the size based on the direction of the thing, but that doesn't make a lot of sense to me, because obviously if the size represents the diagonal of the box, then it doesn't make sense that the width is going to be equal to the size, because it's going to be, I think it's the square root of 2, the relationship. So you take the size of the square and multiply by the square roots of 2 or something like that. Because it's basically Pythagoras theorem. So it's like the hypotenuse to the power of 2 is equal to both sides to the power of 2. So, but obviously it's going to be on 3 dimensions. So it's going to be like del law twice based on the angle, which is based on the height. So I'm gonna see if I can, if I can deduce the width, or I just leave the size and then I just change the threshold, which is the stuff that I'm thinking about doing. But I think I'm only gonna be able to know if I'm gonna have a better idea of whether or not it's working the way that's supposed to after I implement the other parts. So I think that's probably a better thing to do. So before I test, because here, in order to see, like, this, all this code here is based on, is what softviz there produces. So if I implement all of them, then it should be similar, I think. Oh, the other thing I can do is, remember how it's gonna be more complicated. Like I was gonna say, get the same space that I build get basically the graph, the entire graph that I have here on the other one on softviz, and then put that on the other one, because then it's gonna be like one-to-one comparison. But it basically has to be kind of like this. So I think that it can't. It's probably not the expected behavior to keep pushing for the nodes to keep pushing themselves away forever. So it might be something to do with the way that I'm updating the class as well, because I had to add a bunch of functions on the graph node class so that I update the forces. And the one thing that I'm not I'm so sure if it's the same as well is the relationship between the forces on each frame. So this is the parts that I'm going to see now probably. So these parts, and then implement these other solvers here, but these ones are very simple, I think. So this one just gets the length of the vector, which is the position of the node, and then it just multiplies by a parameter that you have on the barn set, which is the central gravity. So central gravity divided by the distance. If the distance is 0, then it becomes 0, because you don't want division by 0, but then you multiply this by the direction, the position of each one. And then all this stuff is adding to the force, and then the force is the one used at the end on the move nodes to calculate the velocity, and the velocity is the thing that is used to update the position. So velocity times the timestamp, which is also a parameter based on the simulation, I think. Yeah, simulation. So it does this calculation here based on other parameters as well, but it's basically getting the acceleration based on mass, force. Then you get the velocity based on the acceleration. Just basically simple physics, I think. Yo, man, thank you. Thanks for the message. And I think that the other solver is this one, which is basically exactly the same implementation as VGS that I just changed here. So this one is kind of more annoying, I think, because, but I can do it with just the, so this edge veer here from VGS is like the points that they use in the middle of the curve to create the Bezier curve. So it's basically the control points of the curve. But I think I'm just going to do it based on the beginning and the end of the edge. So get these points, and then based on the length and the other default value that you have on the barn set parameter, you calculate the force of the spring, which is just K, which is a constant, times X, which is the distance of the thing. And this one, there's also like other calculations that I remember, but I don't remember exactly. Like I think the kinematic force on the spring is a K constant times X, which is the distance to the power of 2 divided by 2. But I don't remember really well. That's the case. But I'm just gonna do like this, I think. So you just get the delta from the two positions. So here is getting from the source to the middle, which is the control points of the curve, and then gets from the middle to the target. So this would be the distance between the two, and then you multiply that by the constant, which is the K on mathematics. So edge length minus distance times K divided by distance. And then you multiply this by the distance. And this is the force, and then you add to the things. I'll be right back. I think that there's probably something wrong because like the gravitational force supposed to attract, I think, the bodies and not repel them. But I'm not really sure because the K is also supposed to attract the spring length. No, the spring force is also supposed to attract the bodies. So I'm not really sure. Like the simplest way to see if it changes is obviously to change the order that I'm doing there to get the distance, because it's a vector force, so if I change the direction of the vector, then obviously it's gonna attract instead of repelling. So there's both this that is repelling, so probably the direction is wrong, and then the magnitude. But I think that the magnitude is more likely that the problem is that I don't have the other forces yet. But even then, it's kind of weird. I think that it should be slightly different, probably. I'm probably gonna do a video or a stream after I finish all of this, just to go over the thing, so it's not very long. Well, so the other thing that I changed is to, instead of using a vector to create the nodes, I'm using a hash map now, because it makes more sense, I think. And I'm not really sure, this might be another thing that I'll have to change, but it seems that it's working now. So I'm not really sure why on the other situations I had to use a node map. It might be for something, I think it was probably for coloring the edges or something like that. But it's, yeah, like it's kind of likely that I'm gonna have to change, because I remember that I spent a bunch of time thinking about this on the previous times, and the conclusion I got to is that either I could use a vector for both edges and nodes, but then I would need another data structure, which is the node map, or I could use a nested map for the nodes. So the first key would be the ID of the node, and then the second one would have the actual map that represents the nodes, or something like that. So, but don't remember really well. But I'm using a map now because it's easier to get the the nodes from the map using the edge. So the edge stores the integer that is the node ID of the source and target. Then I access them based on the map, and then I use them to get a position to update the values of the edge. To update, obviously. So. And this is basically the condition that is reaching the next iterations. And I'm not really sure why is that the case, because it should be updating the values of the boundary of the geometry each time. Yeah, maybe this calculation is not correct. Oh no, but it's gonna divide. Yeah, so it is correct. Yeah. I was gonna say that it's not in the middle there, but never mind. So I think that this is correct. The total mass is just true because there are 2 nodes. So after you create a tree, then you calculate the forces. So I'm passing the root in the beginning. The graph node is the body you're gonna apply the force to. So this is the part that I'm not 100% sure. Because the first node is gonna be... Like, it might be the direction of this thing here. Like the order that I'm doing there. But I think it's the same. So source body is the body you're gonna apply the force to, so is the other one. And like, it shouldn't matter as well because you're getting the difference. Maybe it does matter because of the sign. But I think it is the same. I'm doing basically the same thing. So I'm using the center of mass instead of the body because center of mass just contains the overall mass of the current node, whether it's a space or a body. If there's a body, then the center of mass is just going to be the mass of the body. So I think that the calculation there is correct. It's negative. Then you get the distance. And then this is the part that might be incorrect as well, because I'm doing based on the node size. This is the thing that I was going to look at now. So tree root is the root of the tree. Node space is the box that encapsulates the first geometry. And the size is the diagonal of the box. But on the other one, looks like they are getting the width of the box. So if there isn't an easy way to get the width, I can just do it based on the size. I don't think that's a big deal. but then I should change the threshold theta. Because threshold by default based on the other simulation is 0.5. So you get the magnitude of the size, because the size of vector. So you're getting the length. Divided by the distance. Just the distance between the center of mass of the current node and the body. You're applying the force and seeing if it reaches the threshold. And the length is just gonna be 100. It's gonna be 2. Your R is the thing. It's gonna be on this one. So R is the distance, then you got the width. Yeah. And then if it doesn't reach, then you just recurse on both. So since I have a binary tree, I'm just going left and right based on the subspaces there. So now they're both going to be bodies because they're the two bodies that are added there. So if it is a body, you're always going to calculate the force, which is just the distance. Yeah, it's the same calculation there that I had on the other one. I think this one I got from the... No, it was the other one that I got from the... No, this one I got from the function there. Then to actually apply the force, I'm using the move nodes function that I put inside of the node. Because I'm updating the values on the node. So I create a bunch of setters and getters for... Initially, here's another thing I spent a bunch of time. I made everything to a float, and then I forgot that I can just do a vector tree for each one of them. But then I changed to vector tree, so now everything is a vector tree and has setters and getters for all of them. So there's one function which is the set force, which is just going to update the force with whatever value I have here. But then I created this other one, which is add force, which adds the value to the original force. And this part is the one that I'm not 100% sure. So since I'm never resetting the force on the node, it's just gonna accumulate over time. But obviously, like this shouldn't be a problem, because if the force is a vector, then depending on the direction on the steps of the simulation is either gonna increase or decrease based on the distance. So it shouldn't matter, I think, if you never reset the force. But also, just to see, I did this where I was resetting to 0 each time, and it's obviously going to be the same thing, just a lot slower because we resets the position. So the force and the velocity starts at 0 for the node there, based on the class that I did. And then I'm just setting based on this vector, which is going to be this velocity, calculating like this, times the distance between... these are other parts. So I'm pretty sure that this position here, whenever I have a body, is just going to be the position of the body, I think. Or the difference between the position of the body and the other one that you're applying the force to. So the center of mass is just the position of the body that the node represents. And the mass is the same thing. It's just going to be the mass of the body. So it seems that it is correct. And then this one is going to be the same thing, just adds. So this is the part that I might have to put a check here. This is the one that, because like you shouldn't apply the force on itself. So the distance is 0, so I'm changing to 0.01. But maybe I shouldn't, like if I don't do this, but then it's going to be the division by 0. That's the problem. So like, there's two different situations. One is when you're trying to apply force to the node that created the force, or the nodes, like I'm trying to apply the force of the node on itself, which is the situation here. And the other situation is when you have two different nodes, but they are on the same position for whatever reason. And then on this situation, I think it makes sense to update the distance to a small value. But on the other one, probably not applying is a... So I think that this is the reason why it's probably repelling both of them, because I'm applying the force on the node. So like it's like the node always has a force, regardless of how distance it is. Yeah, that's probably the reason why. So the easiest way to prevent this, obviously, is compare the ID of both of them. So I'm just going to stop here and try that first. So if they have the same, just return. If it's the same node. Let's see if that prevents from exploding. And then this is the other. So after this is one, the applied gravitational force is like the conversion between move nodes from the other project into this class here. So because this one is going to take into consideration all the forces that were applied by the different solvers into the final calculation, which is the actual calculation of force. Just getting the acceleration based on the parameters as well. Just force divided by mass. And you get this delta F, which is based on damping, which is another value from the parameters. So you just... I think, yeah, it's just a multiplier on the velocity. So then based on this velocity, which is a member variable of the node, you're going to... These checks are just to prevent division by 0 or whatever. It doesn't matter that much. So I got the position of the nodes, then I increase the position based on the velocity, and then I update the position. It's not that complicated. And then here is the part that's another thing that might be wrong, that I'm not really sure what's going on. Also, it looks like it is... Oh, but it should be right, because it has to be based on the values. Like the vectors that represent the minimum and maximum have to be based on the positions of the extremes of the geometry. Oh, so I think this is the reason, because I'm updating both nodes. Oh no, but I'm gonna loop over all of them. So never mind. I think it's gonna be... Yeah, there's something weird going on with this thing here, because on the next iteration, I'm getting the warning that they are not on the geometry. So I'm just gonna press F5, I'm gonna go quickly over this, then compile again, try again. The parts, the other thing that I was doing here is to delete the nodes later. So because these are parts that I'm not really sure what to do. Because I think it is probably like very complicated to... Ideally, you only do the tree once, and then you just rebalance the tree based on the new positions. So I think like the best way is probably if you can just create the tree once, and then you do everything from the tree, because the tree should hold the states of the space that is separated. And then all the movements of the nodes after that is just a rebalancing of the spaces that make up the tree. But I think it's probably massively It's probably very complicated to rebalance. But I'm not really sure if it's worth spending time on this, because I do think that I'm probably going to spend more time on this either now or later, because I know there's something there that's very, it's fundamental to everything. Because the fundamental principle is partitioning a space based on a tree data structure. So the tree is like the tree encodes causality, I think, or something like that. Because it's like the chain connection of events based on a space relative to a reference frame. So the way that you partition the space matters is another fundamental thing. And the way that you update the partitioning on each frame is also like something important, I think. And I think that probably this other fundamental pattern is probably worth spending time thinking about, which is maybe I'll do it in steps. So I do this one first, which is to, based on a tree, how do you update the forces from the tree itself? So you get like the thing is, intuitively, I think that it makes sense that like there should be a way for just to get the entire state of the tree right away and apply the state of the tree on each external node that it has without having to loop outside. That's the thing. Because the state of the tree already should have all the forces necessary for each node. So I think that the calculation of the forces are encoded in the connection of the tree. So it makes more sense to me that you shouldn't have to loop over all the nodes again and calculate for each one. There should be a way based on the nodes from the tree to update its state, the force on it based on the state of the tree. But I'm not really sure. Like thinking about the details is kind of hard. I'm not really sure if I need another data structure, or the way that I'm imagining in my mind is like if you imagine a tree, it's like updating the color of the tree, let's say, from the nodes every time you want to calculate the force. I think that this is the problem, is that I'm not really sure if the relationship is both ways, like if it's just from the top down that you can do, or from the bottom up. Because the difference is the threshold, I think. So the threshold works top down because when you're traversing the tree top down, it's like you're exploring space based on the branch. It's very similar to poker as well, but I think because of imperfect information, probably is like you lose entropy. Like you have entropy, so you can't reverse the process in the same way. It doesn't make sense to go from the external node to the top. But maybe it does make sense. Yeah, I think that this is the question. Probably this is what I have to explore. So maybe if I just try, like, yeah, I think that's probably the most interesting. But I have to make sure that the simulation is right first. So once I'm probably gonna explore this, which is to like create an algorithm that tries to goes from the bottom of the tree. So without getting anything external, because the way that I'm building the tree is already going to have a pointer to the node, to all the nodes that I need from the graph. So the tree should have the state of the graph already. So like calculating the forces is just updating the state of each node of the tree based on the relationship that the tree already has encoded in itself. And the travel distance from each node is kind of like a star algorithm, which is just like the traversal of the tree based on a heuristic. So it's like if you imagine a tree on a forest that everything, like all the nodes are dark, and as you traverse, you put light on the nodes. The range of the light is determined by the theta threshold. So based on the range, there should be a way to get the whole states of the tree, I think, and then apply the force right away without having to traverse the tree for each one of the nodes. So I think it's worth to think about that probably. So this is one part, and the other one that I'm not 100% sure is whether or not it's worth it to spend time thinking about how to just update the tree without having to recreate and delete each time. Because if that was possible, then instead of creating the tree on the update simulation step, I would create right after I create the graph, so create only once, and then inside of the simulation, just update the state of the tree based on the movement. And if you think about it, what is happening is just each frame, the broken down, like the structure of the broken down space is just shifting based on the relationship between the relative positions of the nodes. That's mainly what's happening. So the restructure of the tree is just basically the movement of the space in relationship to the nodes over a reference frame, which is the reference frame from each node, perceiving the rest of the geometry, because that's going to determine the search space. I'm just gonna, because it's fucked up there, I'm just gonna compile again, because I changed the thing there. So I'm gonna compile and I'm gonna open from the editor to see. Yeah, so I have to put the condition here, I think. Another condition. Oh, I put here, yeah, I already put, so. This should prevent the force from re-applying on itself. So maybe this is gonna stop the thing from going for infinity. Exploding. I do think there is something very deep here, which is basically like the separation because of the stuff with the electromagnetic field that people say, which I agree. I think that is the view that makes sense, that the universe is electromagnetic. So what creates geometry and what creates time is the pressure mediation between the two different poles of the electromagnetic field. And the difference between things is just the density of the frequency. So, and I think that is basically the same thing that's is happening here. So depending on which way you break down the space is going to create a different structure. So like the division of the box creates the structure of the space around the geometry. that creates the calculation of force. Because there's another way to do it as well. I think there's two different standard ways to do it. One is to consider that everything is a box, which is the way that I'm doing now. And then from the box, you just subdivide the space in boxes. And the other way is to use a sphere. But obviously, there's also an infinite amount of ways to subdivide. So what if you try to subdivide based on the electromagnetic field? You subdivide based on the torus. And then like I get the calculation of, or I get the, I think it's phi, the name of the ratio that creates the torus. And there should be a way to fractally divide the space based on this pressure mediation. It is kind of fractally dividing already because it's using recursion, so. And I think that the range of the subdivision determines the pattern of the fractal. The heuristic you put to subdivide the space determines the fractal pattern, and also the order in which you subdivide the nodes. The order in which node you put first on the tree, I think it matters, probably, because it's going to determine the first subdivision. As it still looks like it is exploding. There has to be something else. Or easy thing to try to do is change these values here. So let me put like this. Because this is kind of the issue. And maybe this has to be positive, but like the other one I know for sure is a negative value. So obviously just based on the calculation here, it has to be exploding because the distance is not strong enough to offset the value here. But the thing is that on the other one, like I remember even on the VGS one, you have to put a very small value so that they're further apart. It might be because of the other forces, I'm not really sure. Yeah, because it should be, like the total mass is just going to be 1 in this situation. Because the theta is not being reached. So it's just going to be, like the force is just going to be one body to the other. Which is going to be 1 times 1 times the gravitational constants divided by the distance to the power of 3. The distance I think is 100, negative 100 on the x-axis. So it's just going to be 10 probably. No, it's going to be 100 because it's just 100 power, so it cancels out. So I think 100 times 3 is going to give whatever. It's 10,000 here, and then that's... Yeah, so minus 2. So this is the thing that is weird, because it's supposed to be 1 million here. So minus 2,000 divided by 1 million. and this multiplied by the thing. So it should be a very small force. So let's see. We're about 100 on each one. It's gonna be moving 0.2 on negative. Hey, what's up? So I think it might be because of the cumulative effect of the force. So there's probably something with this as well. It's kind of, it might be because of like both things, that I don't have the other forces yet, and because of the cumulative effect. Because I think that, but on the other one, like, this is what is weird to me, because the other one is supposed, like, this is the node that I have there on the other parts. So it's just going to be updating the force here, and then it's going to use this here. So the velocity here is also from the... Oh, so it might be because of this. No, but... so maybe I should be making equal to 0 each time. Because I think that, like, it might be because it's updating only the velocity from here, and it doesn't update on the nodes. So like this, I think that it shouldn't be because I'm not resetting, because here is supposed to be updating on each frame. So like I'm not resetting this as far as I remember on each thing. So the position here is going to be the position of the sphere there. I'm pretty sure about this. I'm doing based on this thing here. Yeah, so I think it has to be something based on the way that I'm doing the calculation there inside of the thing. It should accumulate each time because it shouldn't matter. So it is accumulating the velocity of the nodes. But maybe that's the thing, I'm not really sure. Because it might be that it's supposed to accumulate the velocities, but not the force. And the way that I'm doing there on the other one is accumulating both of them on each time. So it should be accumulating here. So it updates here. Then it updates here. Updates here. It might be because of this. And then it moves. So I do think that it is accumulating always both the velocity and the force. So it calculates the force first and then updates. Yeah, GG. But now it's better because it's only showing this twice. So maybe the boundary was fixed, the geometry. So it doesn't really matter that shows this sometimes. So I guess the next thing to try is to just change the order. There's a problem. So maybe I should put... this is an issue. I'm not really sure how they deal with this, but whenever you have a space, how do you make sure that the... But I think for the space, it doesn't matter that the node counts. The force of the node counts on its own, but maybe it does. Maybe that's what it makes it explode there. So like I prevented the force of the node from being applied on itself here, but on the space, it's hard to think about because obviously, like how are you going to? But since it's like the whole body, maybe it doesn't matter. I think it doesn't matter. It's probably because of something else that is not working. So what I can try to do is just change the order, which I'm doing here. Now I'm gonna try that first. Because it's gonna be annoying to figure out the other stuff by looking into the other code because he uses a queue, not it doesn't recurse, so it's more annoying to figure out. I think it shouldn't matter because it's just a difference. Yes. Maybe it does matter. Not really sure. The direction obviously matter because of vector force. But I think it makes more sense. Oh, maybe this does make more sense because you want the distance from the body. You're trying to apply the force to whatever the center of mass is. This is weird. Hmm. I didn't change anything that this should make the memory blow up. Oh, it's because I have this one open, maybe. Hmm. Might be because of this. So it might be... So it might be because of the way that I'm doing the subdivision that I'm getting the wrong thing there. Because the error that I put there on the to calculate the forces is not, or to add the nodes. Maybe not. So the x is 100. Distance is 100. It should be 1 million. Velocity is very small. Velocity times, I think. So the force should be very small here. Return. So velocity. Oh, this might be an issue. So it might be the case that the velocity there that I have to update is the velocity on the node. This might be one difference. But I'm not really sure. Because the V here, so where does this come from? Over here. But it might be a problem actually. Because here, no, it's just setting each time. So I think it's the same thing. But like this velocity is not related to the node. It stores everything on the force. Then only later uses the velocity. But yeah, so let me continue. Yeah, I think later it does change the velocity on the node based on this. I don't understand because it seems that the values are right. The only thing that makes can potentially be wrong is the direction, but I changed there, so that doesn't make sense. Let me just go over the way that it is now. Because I'm pretty sure it's blowing up, so I'm gonna test again, like switch the thing again and then step over to see. Because based on the values there, it seems that it's correct. So it's increasing very, like not that much on each iteration. The position based on the force, which is very small. But obviously the direction, the sign of the force is gonna change the in which direction the nodes go. So that's why I thought, like, it might be because of the order here, but or it might be because I have to. So yeah, but I think that if I do two changes, then it doesn't matter. Like if I change the order here and then change the sign of the gravitational constant, it doesn't. I'm gonna put this as a negative again because the other one is negative. So I'm gonna test with this as negative first, then I'll test the. I'm gonna switch the order again to see if it still blows up. If both of them. I think ideally, like, it could be the magnitude as well. So like what I can do is just change the magnitude because like maybe it's supposed to blow up in that situation, and it's just like because of the magnitude of the forces, but it's supposed to stop at some point, I think. Because the greater the distance, the weaker the force, or vice versa. I think, yeah. Yeah, so greater the distance, the weaker the force, I think. I'm not really sure though. And this is another problem here. It's saying that it's outside of the geometry. It can be because of the way that I'm breaking down the spaces. I'm not really sure now. Because I think it makes more sense that it's supposed to attract the two different things, and it should become weaker with the distance. Yeah, I think that makes sense. So like the greater the distance, the weaker the force, and it should attract the two different things. I'll be right back. I think I understand what's going on. So the problem is the space. So it's basically the way that I'm getting the boundaries, I think, of the geometry, because like if I get the error message, then it means that it's not on the next iteration is not adding, it's not creating the tree. So it means that is always going to be the same force. So the force doesn't update based on the distance because it's always the same. And because I'm not resetting, which, but even when I was resetting, wasn't correct. So but it might be just because of the structure of the tree. Because it's basically this error message that is showing there. So if the body position, so this is when it's supposed to be a space. It's a space that doesn't have children. So it's the root of the tree, I think. Because it only has 2 nodes, so that's the only situation where it makes sense. So I think it's because of the body is outside of the box. But that wouldn't make a lot of sense, though. I have to go over more iterations with the... I should... yeah, I'm gonna put a breakpoint on the error message there. So put a breakpoint here. Because I think that it might be because of that. Yeah, but I think, yeah, I'm pretty sure, because like what's happening is that it calculates the force. Yeah, but I was gonna say, like, it calculates the force of the first time, and then it doesn't recreate the tree on each iteration. So the force is always constant and makes it, because the first force moves the nodes away, is always making them move away. But the thing that doesn't make sense is that I remember, like, I was resetting the forces at some point. But it might be because of the 2 different things. So I'm gonna test if I reset the force now, what happens there. Even if it is something like that, it's still kind of weird because it should be attracting, maybe. So like, it's the direction of the vector of the force that is not correct as well, I think. The initial vector should be for both of them attracting each other, I think. Maybe not, actually. No, yeah, it should be. Because if it wasn't strong enough, then they should be just standing still. So the first direction should be for them to be attracting each other. Oh, so now, interesting. So now they're getting close and then it blows up. It's because of this thing here. Yeah, so what I'm gonna do is just, I'm gonna reset the force, but the problem is when you reset the force, but I can change the magnitude. I'm gonna put a very large, like a much larger value on the barn set. And then I'm going to, because the magnitude is impacted by this, I'm gonna put like 100,000. 1, 2, 3. And then I'm gonna reset the forces each time. Yeah, so it might be better just because it's also easier. Like the only reason why I did things this way, because it saves computation. I think if you, like, if I update the minimum and maximum here, I don't have to loop again. This is kind of the problem. Because in the other way, the other thing here, the way that it was being done is that each time you create the tree, it loops over all the nodes first. Just kind of like doing a double thing. But it's not that bad because it's not going to be O(n) to the power 2, it's just 2 different loops. So because it increases the amount of loops and not the... It doesn't do a nested loop. So it's not that bad, but... So it might be just easier and safer to do this way. Because then it ensures that the thing is always going to have... Yeah, it's on this function here. So here... I think it's on this part here. It's on this loop here. Yeah, this one, maybe. So they are using a stack to add the nodes. So they're doing breadth first search. And then they basically... maybe it's not this one. Where is the thing? Oh, so it's here. Yeah, here. Yeah, this is the loop. So here they start at the boundary, a very large space, and then based on the... They do the loop over all the bodies here, and then they get the vertices based on this. So, yeah, one thing that I can do is just do the same thing there instead of doing the way that I'm doing. It might be just better. I think what's happening there is that they get very close until they reach the same position and then it blows up because of the division. So there might be something. So the other thing that I can try to do, because even if you're updating correctly there, well, it has to do with the boundaries, I think. Because here, this condition should only be when the initial box is fits. Because every time later that this is gonna be... that this branch is gonna hit is when you have a subspace, and when you have a subspace, the subspace is gonna have children. So it's not gonna be no pointer here. So the only situation where this error message shows up is on the roots of the tree, I think. This is whenever the first node is outside of the boundaries of the first space, which is the space created by the root, which happens outside. Which is basically this calculation here. Also, I can delete this function I was doing here, but then just simplify, put it here. It's better to wait here first. It's gonna take a long time, I think. Maybe not because I increased the force, but... Hmm. Now it's not blowing up as well. That's weird. I didn't change anything there. I'm just resetting the force to 0. And that's why it's fluctuating. Also, the other thing should do. Hmm. Maybe it's the way that I'm updating the thing as well. I just... But... It's the way it is. I'm gonna change again the direction here. It's the 50. I don't know if it's because it was going very fast, or if there's something going on with the source and target of the edges, because it looked like the arrow was flipping between the two different positions. So I'm not really sure. Like, the issue is the way that I'm doing the... But I think it might be because it was flipping between the two different nodes. So it might be something like that. Because of the way that I'm updating the edges here. It should be the idea. Because the way that I'm creating is based on the... Like here is gonna be 0 index. And it's gonna be 0 here, so I don't know idea. So the index of the hash map is the same as the ID of the node. So it should be the same, I think. Obviously, the other thing that I can try is just go back to the way that the function was being there of the subspace. I think the first thing to try is to change the way that I'm updating the minimum maximum here. So I should probably change the function instead of the thing, so that it loops over all the nodes and gets the minimum maximum based on the... to just copy from the other one. Yeah, that's probably the best thing to do now. It should be on here. And then I'll have to update. And now it's just gonna go to infinity. This can be another problem that I was thinking about, which is the arrow. I'm not really sure if it's just my eye, but I think it's like the problem is that the arrow is stretching the bigger the curve gets. And I'm pretty sure, because I'm doing the arrow now, I'm pretty sure based on the curve length, or to maintain the size, but it looks like it is like shrinking the arrow the bigger the curve gets. But I think it looks like that because the ratio is the same. It's like the size of the arrow is always the same, but because the thing increases, it looks like it is smaller. But I'm not really sure though. So it does look like it is changing, so like the only thing that I'm gonna have to do is just change the relationship, which might be annoying. So like as the curve length increases, then like shrink the arrow by some amount, because it has to be consistent across like the lengths. It might be annoying to do this. So instead of changing the order, it's easier to just change the sign here. But it is kind of weird because like it should be the same thing. Because on this one is negative, the gravitational force. And the node is the center of mass. So it should, like I'm doing the same order. Center of mass. Where's the body? So like I shouldn't have to invert the sign to make them attract each other. But maybe like the thing is I'm not really sure if the other one, based on the sign that I have there, if it was also attracting or repelling. But obviously it makes more sense to attract. But it's been a long time since I've done that one, so maybe I got it wrong when I did on the thing. Because it might be because of the other forces that are balancing out, the other solvers, so it makes it not repel even for the value. Yeah, I'm gonna put a smaller value. Just see what's going on. Less iteration that I'm gonna see there. Then I'm gonna change the minimum maximum vertex. Just see if it stops. And then I'm gonna think about this sign thing. Because it should be negative here and it should be working. Like, but because like it has been a long time since I changed this one. I don't remember really well. If I change here and I commit and push the changes, if it's gonna show there. Because obviously I can just change the solver here, comment out these other ones and see if the visualization there is gonna be correct. But I don't wanna do that. And I'm not really sure if it's worth it to add these other solvers before, or yeah, before trying to fix the other thing. Because it just might be more confusing to... Oh, so here it might be the difference. Yeah, I think this is the difference. I didn't realize this, but like here is making it equal, so it's like resetting the force each time. So it's not, the forces are not supposed to accumulate each time, I think. They're just make based on the position of the nodes and the gravity force. Yeah, I think this is the main difference. I didn't realize this. The spring, pretty sure. Yeah, the spring is increasing or decreasing based on the direction. So I do think that based on this, I am supposed to reset there. But it doesn't matter if you reset to 0 or some other value, because it's just gonna change the magnitude, I think. But maybe it does because like this is resetting accordingly to the negative value of the position. So maybe it's better to add this first, just see if it's gonna solve there, the other one. Now that I think about it, it does make sense for the negative value to repel actually, because when you decrease the value here, they become further apart. Oh, it's because like the only thing holding them together is the gravitational force. And so it makes sense, but like it's not intuitive to think about because obviously that's not how it works in reality. Like it is how it works, but like in reality you always have the gravity by default, obviously. So like here it just changes based on the way you change the value here. So it's not like the force is repelling, it's just readjusting the state of the simulation based on the force. I think this is the reason why it might be repelling there. So it might be correct. So it should be a negative value. It's just the magnitude. But it's still, yeah, I'm not really sure though, because like maybe it's the other forces that are balancing out. So I guess like you have to change the magnitudes. So put the minus and then change the yeah, but it might be because it doesn't have the other forces. So I think that these two things is one is the boundary of the geometry there. It's probably better to do it inside as I create the tree. And the other is because the other simulation doesn't have the other forces. So it might be because when I put the positive value, it does go the other way around. So like the problem is that when you put too much, then it becomes unstable, I think. Yeah, but I'm not really sure. I do know that here there's also some situations where it becomes unstable as well. Because when it's 0, everything's gonna go to the same spot, I think. And then it's gonna become unstable because you can't break down the space. Let's put 0. And this is weird. I think it's just taking a lot of time, but it's gonna put everything together. So maybe positive values make it go. But it doesn't make sense. Yeah, the positive values make it so that It's like trying to converge to the same spot. That's why it's rotating, I think. So it might be because of the I should put 0 there, or a negative value very close to 0. Let's see. So there's three main differences. One is the baseline on the other one that is based on this one, which is based on the negative position times this constant here, divided by the length of the vector. So it starts everything always based on this. Then the other thing is the limit of the nodes, because it seems that they are breaking out of the first space. So I should move, I'm gonna move inside of the create tree function, the calculation to get the limits of the geometry. So just loop over all the nodes each time, then get the boundaries based on all the nodes. I have to see how to get a very large value on C++. And the other one might be because I don't have the other forces, so the magnitudes should be different. You get them roughly in the same distance from the one that I have on the front end. I think once I fix those three things, probably it's gonna be closer to the other one. I'm just curious to see here, is lower, what's gonna happen. Yeah, so this is the thing. You get very close, and then because the force is positive, they're always trying to get to the same spots. And then when they get, so I think that this separation here is based on the distance that I put there. So I think one thing that's might be interesting to test is if I decrease the range, because it's both based on the magnitude of the force and the distance that I have there to prevent it from being 0, I think. So this distance here, I think you might complain because of the double. I don't know why I didn't put this here as well. It might be because of this as well. Yeah, but then we would break, but obviously. The center of mass could be at distance 0 from the position. So I think I just forgot to put here. So after I test this, I'm going to test with a very small negative value to see if they, because like I want to see if they're going to stop at a certain position, because that would be the correct thing to do, I think. If they do stop at a certain negative value, then just because of the magnitude, I think that the range of the gravitational force is going to determine on the simulation at where the relationship between the bodies you have on the simulation. So this is the thing that is unnatural and it's kind of weird, because obviously it doesn't make sense for them to repulse based on gravitational force, but it's not that they are repulsing, it's that I'm initializing the simulation at a certain position, but the gravitational constant requires that they are on different states, because there isn't any external force on the simulation besides the gravitational force between the two different bodies. So it does make sense. Yeah, so they do touch there, I think. Interesting. But it doesn't seem that the value there of the distance changes much. So the next thing I'm gonna do is put a very small value here. A very close to 0. Or maybe I decrease this. Yeah, but the distance doesn't matter, I think. Yeah, I think like this distance that I'm putting here is not gonna change because it's only gonna reach this when it gets to 0. So yeah, so it should be bigger actually if I want to decrease the. I'm gonna test a bigger value to decrease the range, because I think what is happening there is that because the force is positive, they are trying to get on the same point, because that would be the correct state for the simulation with that gravitational force. Because the only forces acting on the bodies is the gravitational force between them. So when the constant is positive, it makes them want to be on the same place. But then when it gets to the distance 0, I reassign the value, and then it immediately puts them on a certain range based on the distance here. And because the distance is small, the velocity becomes greater. So it makes them have that pattern. I think that's what's happening. Hey man, what's up? Barn, so it's a solver or algorithm, or either solver or algorithm is a way to compute gravitational force on a body. And I think it is usually used for graphs. I'm gonna make a video probably, or another stream, explaining what I'm doing here once I see that it is working. Like obviously, before I explain either on the stream on a video how everything that I did, I'm going to say that I'm not 100% sure if this is the correct way to do it or not, because the way that I'm doing is different than the way that usually is done. But I'm gonna try to explain like the fundamental principles behind the thing, because it's actually easier than it seems, but it takes some time to understand because it's kind of confusing in the beginning. No, so far it's been a long time. So someone's asking about donations on the crypto wallet. Sometimes it's been a long time since I haven't seen the wallet, but yeah, no. But I think it's just because I've seen from other people that have a much larger following. Sometimes they get, but I think it's not very common because probably not a lot of people use crypto. So I think it's probably a lot more common to get based on normal donations from Streamlabs or TTS or whatever. Well, hopefully that's gonna change in the future. I think that probably the most likely thing that should happen over time is that crypto is gonna be somehow. I don't think that the current state of crypto works for this, but probably it will be developed to the point where the infrastructure of society is going to be built on top of crypto, but the end user is not going to use it directly. So it's like going to be banks and institutions and everything that is built on top of the crypto network. And then they're going to take the risk in order to get the rewards. Because the biggest problem with crypto is that if you lose your wallet or get hacked or whatever, you're fucked, and that doesn't make a lot of sense. So like, you need a funnel. You can't have something that is fully decentralized. And right now the funnel is centralized exchanges and everything is corrupt. But that's how it always starts with everything, so. It might be like very small values, so it doesn't do anything. But it does look like it is. So maybe I should increase the volume. But I do think it's working now. So yeah, I'm gonna put on the steps there as well. So I think it was always working, it's just the magnitude of the values. So the biggest problem is this one. I'm gonna have to fix now. So I'm gonna fix this now, and I'm gonna write down on the steps there. To fix the arrow, just see if there is, or what should I do. But I need to solve all the other stuff first. I would say someone's asking how proficient I am with using Godot. I would say that's like probably like I don't know, I don't have a lot of knowledge on the nodes, but like I'm proficient. I understand a lot about the engine and the source code, but I don't have a lot of practice building stuff with it yet. So like I don't know the specifics of the nodes, but I understand very well how everything works now, and how everything is connected and how it works. There are some parts that I don't understand yet, that I didn't spend time. So mainly the audio and the multiplayer parts, I didn't spend too much time understanding. But the rest, I think I understand very well how everything works. So I spent a bunch of time just stepping over the source code. And I basically streamed everything. So let me search. But yeah, it depends. Like, what do you want to learn, or what do you want to know? Because I might be able to help you understand. But basically, I spent a bunch of time just first I learned how to build the thing using scones. Then I spent a bunch of time studying the build system. Then I spent a bunch of time stepping over the code. And then I spent a bunch of time looking into the GUI and then searching for tooltips, the things, and then I search for whatever shows up on the tooltip on the source code. So like the phrases. So the first thing that I studied was the export system. So I got the whatever shows up on the GUI, and then you search on the source code, then you put breakpoints on the source code, and then you go over the whole pipeline of actions, like you go over from the editor first to understand, then based on that you put breakpoints on the code, then you step over, and then you, like I created a map of what actions happen on the editor and what's happening on the code. And then I did this a couple of times for a bunch of parts, and now understand like a lot. But I don't have a lot of practice using building stuff yet, so I need to study a lot more on like mainly how the rendering pipeline. Like I do understand the like I understand the driver roughly, the parts on the driver of setting up the driver, but I don't understand the pipeline from the top of how the shader selection is used by the classes and then how that's going to interact with the servers. So that one I have to clarify a lot more, and also the pipeline, not the pipeline, but how the different member variables of each class are going to change the everything. And the engine is very big, so there's also a lot of stuff, like visual shaders, for example, and custom shaders and this kind of stuff. I have no idea. So I have to spend a bunch of time more studying to see. But it gets easier every time, obviously, because you learn how it works, and then obviously the more times you do it, the easier it becomes to learn everything else. Sort of, because like the thing about I wouldn't say I'm pretty comfortable with C++, because the thing about working on Godot is that they already handled most of this stuff for you by building the classes that manage memory and stuff like that. So like you mainly work with the abstractions that they built already. So there isn't many things that are very different from other high-level languages. The main difference is the types, but it's very similar to like Python, JavaScript, stuff like that. So I don't feel that much of a difference. I think the C++ gets very hard when you have when you're building a bunch of classes together, and when you're using like pointers to pointers and function pointers and deduction of types and stuff like that. That's when it starts to get very difficult, because then you have the difference between right-hand side, left-hand side. But I'm not really sure, because I never like worked on anything outside of Godot, I think, on C++. I'm gonna put a function here. I'm gonna change this one actually. So the main difference on this one is gonna be that I'm gonna find the maximum and minimum here. And I'm just gonna copy from the other one. So instead of doing what I'm doing now, I'm just gonna loop over the entire graph when I create the tree to get the minimum and maximum, and I'm gonna see if that solves the error that I'm getting there. So they took care of a great deal of abstracting stuff away, so it would be necessary to look inside the engine at a lower level with the help, or whether when it will with that help. Yeah, it definitely does, but it definitely helps a lot. The way that I think about it is more like looking at the source code is more understanding the fundamental principles that they use to build, and the design principles as well, and understanding how everything is connected. But looking at the engine is different than coding the engine yourself, obviously, because the hard part always when you're like most of the time, the hard part when you're coding is figuring out which of the approaches is the best one and how it's going to evolve over time. So when you're looking at someone else's code, they already made the decisions for you. So like, and it's not, you don't have to come up with them, but obviously you can still like analyze from outside to see like, do I agree with that design decision or not? But changing the thing is a lot harder. So like one thing that I didn't like that much, for example, on Godot, I think there's three main things. One is the signals, the way that they build the signals. The other one is the way that they build the calculations for the matrices, which they use the transform 3D class. And the other one is the object-oriented approach, because it seems that for my situation it would be better to have entity component system, which is a more composition approach, because it seems that entity component system works better when you have a lot of data. So I think it makes like more sense for most situations probably to have entity component system for something like an engine. But at the same time, I'm not 100% sure. But like to change the Godot from object-oriented to an entity component system would be extremely difficult, because you would have to change a bunch of different things. So, but understanding that it is using object-oriented is a lot easier, because you just look at the classes. And there is a version of Godot that is entity component system as well. So you can look into that as well and compare both of them. But I didn't do this yet. So it's this Godot's version here. So it might be something else that I changed. I'm gonna put 0 and see what happens. Let me put 0, 0. It depends on your background. Of course it does. Because it's like, not sure what is a good analogy. Is a relationship between like short-term reward and long-term thinking. It's going to impact everything in your life, basically. It's the way you approach things. So it's like, because every action you take becomes a habit becomes your personality becomes character. So the way you see one thing is the way you're going to see everything else. So the mistake is like, is the difference between, for example, writing something on codes and then searching what to do each time, or spending like 5 hours memorizing and never having to search again. On the beginning, the person that searches each time that they need is going to be faster, but over the long term, because all the decisions are going to compound, they're going to be a lot slower, because they are avoiding doing the short-term work, because they want to build stuff fast, but then over the long time, everything compounds, and then they end up doing a lot more work, because they're trying to avoid doing the work. And then it takes a lot longer, paradoxically. But if you put all the work up front, then after you do that, everything becomes easier, because it's automatic, because you understand how everything works. So it's a lot. So on the short, and that's why I think it's automation is an exponential curve, because in the beginning it looks like a straight line where it doesn't grow that much, but it reaches a certain tipping point where everything is automated, so it grows exponentially. So in the beginning is like a relationship between, let me show on SkyDraw. So it shouldn't matter the specifics here, but I have like a Cartesian plane here, x and y. So the person number 1 would be like this. And the person number 2 is like this. So this is the person that avoids looking into the source code. Uh, and that's why it depends on your background, because so usually what's going to happen is that 80% of the people are going to follow this straight line here. So it looks like they are winning in the short term. And this one follows an exponential, so it looks like they are very slow. But then it reaches this breakpoint of automation where the slow becomes exponential. And this one is still linear. And that's when people switch, like the flip. So it's the winner's bias or whatever you say that. Like when people look back at it, they change their minds of how it is. Because their body is tricking them into saving energy in the short term. And based on social structures, it's always going to be like, this is why it's kind of pointless to argue this kind of stuff, because it's just based on the genetics and the environment. So like 80% of the people are going to follow the straight line because of Occam's razor. So the combination of these two lines here is going to create a wave function, because this line here is determined by a Gaussian distribution, which is a normal probabilistic distribution, which is a consequence of genetic mutation. And the other one is based on the competition between people that creates hierarchy, which is determined by the markets, because it's going to create a fractal pattern that is like a Gaussian curve becoming exponential curve based on supply and demand, which is the relationship between the limbic system and the prefrontal cortex. So based on the market forces and the complexity of the environment is going to create a wave of computation of the collective consciousness. And it doesn't matter what you say, that's always going to be like the natural progression of everything. So most people are going to follow the save energy on the short term for a variety of different reasons, and then a small percentage is gonna, because the slow prototyping curve has more risk in the short term, and that's the reason why a smaller percentage follows this, because it's like a sphere. So like the center of the sphere is safer, which is the fast prototyping curve, and the edge of the sphere is riskier. And it's exactly what happens in nature when you have a herd of animals, for example. So like when you have a bunch of zebras on the jungle, the lions are going to attack the ones that are outside. So it's a lot safer to be inside of the herd, but then there's less rewards. So it maximizes energy and minimizes efficiency to be that on the short term, but then on the long term, there's a flip that happens. So yeah, it depends on the circumstance. It's not about like trying to be slow. Like both of these people are trying to be fast. It's about the hierarchy of importance of each thing. So obviously we're gonna try to be as fast as possible. So like, and there's different magnitudes for different things. Like obviously AI, regardless of which curve AI takes, is gonna be faster than a human in certain things, because it has more processing power. So it's like trying to reduce infinity into scientific paradigm. It's not gonna work because it's subjective. So I think this applies to everything in life. It's like you can't reduce quality based on quantity. Uh, there is a gradient there where there's going to be a multifractal line, but that's always going to be relative. So, like, it's the question of what kind of diet is better. Like, there isn't a diet that is better. There isn't a decision that is better. So, like, it's not like sinning is a bad thing. It's just that there's actions and reactions, and the only person that can tell if something is bad or good is you, because it's based on subjective experience. So the only assessment you can make is that, like, if you punch that wall really hard, your hand's gonna hurt, but you can't make an accurate assessment of whether or not you should punch the wall, because that's gonna depend on whatever you want to experience, which is always gonna be subjective. So there's always going to be trade-offs for everything. It's not that the fast prototyping is worse than the slow prototyping. It's a matter of values. So it is subjective by nature. So the idea is, if you want to make a game, you do rapid prototyping iterations over a list of ideas until you feel you have the right one at that point. From scratch, or are we doing it the right way? I'm not sure. Not sure. I'm not sure if that's the right way to look into it. Because I'm not speaking about the... Like, it's not about the relationship between the amount of games and... Yeah, I think that's a different thing, but I'm not really sure. Like, it's more about understanding the fundamental principles, not the idea. Like, this is what I'm trying to say. Like, it's gonna be impossible to... Like, if that answer existed, then, like, everything would be solved instantaneously, because you were basically asking, like, what is the optimal strategy? And that's, like, gonna be the whole thing. It's always gonna be relative. So, like, it's not about... It's the same thing with money and everything else. Like, it's not about focusing on the money or everything else. It's just focusing on the skill, which is what you can control. It's not about... I'm not talking about, like, prototyping on that way. I'm talking about, like... Because, like, you said prototyping there, but it's not really prototyping. It's just understanding of the fundamental skills. Like, so, like, this would be, for example... I think front-end is a lot easier to understand. So, like, this would be, for example, learning React. This would be learning math and physics. Like, on the superficial level, it makes more sense to learn React because that's what people ask for jobs. And then people say, you don't need to know mathematics or physics to know how to code. That's partially true, but coding and mathematics is math and physics, because those are the fundamental principles that make up what computers are. So in the short term, if you do understand math and physics very well, it's going to be very easy for you to learn other things. But it's not only math and physics, you have to know math and physics in the context of computation. So, like, the fundamental principles that make up a computer and what it means for a computer to compute. And this whole pathway of the fundamental principles of mathematics and physics and how it relates to the concepts you're going to use on the framework. So this is a lot slower, but once you get it, then everything else becomes easier. It's just like building businesses and everything else. It's not about the business or the money. It's about the fundamental skills that give you the result consistently. So because the results are going to be outside of your control. So you can't reduce into, if I try this amount of times, it's going to definitely work. It's more how to increase the probabilities that it can work more times, I think. Yeah, but it depends. So I do think that it is correct. Like at first you don't care about optimizations, but it depends on your background and everything. So like there isn't a black and white answer, I think, to this. Because like think about Barnstad, for example. So like maybe it doesn't matter to apply Barnstad on a game, but if you understand fundamentally how to apply Barnstad, and it becomes a lot easier for you to apply Barnstad, then it doesn't become difficult to do the optimization because it's already natural for you. So it's not about, I'm going to apply Barnstad on this specific situation. It's about my understanding of how the fundamental principles of mathematics impact the dynamics of a game. So once you understand the fundamentals, every iteration after that becomes easier. It's not about the amount of iterations, it's how much you understand what it means to do something. Not sure if I changed something that fucked the thing out there. It shouldn't be that. Yeah, I'm gonna try minus 2000 again. But minus 1000 should already be like high enough, I think, to have an impact there. So maybe I changed something else. But I'm gonna, let me change the, I'm just gonna copy the way that they do it there. So I'm gonna ask ChatGPT how to get. Oh, this. I think I was just gonna right here. The desire to not one should know these things as well, and like the whole thing about retirement and stuff like that. It's just the body trying to minimize energy and risk. So because the body is not smart enough to understand the circumstances, so there's always this fight between the body and the mind. Because the body is constantly trying to get to a place where it doesn't have to do anything. But that's an illusion because that's never going to happen on space and time. Because as long as space and time exists, you're gonna have to, like, changes are gonna happen, you're gonna have to put in the work. So I think that the vast majority of people, based on the market's dynamics, is gonna try to minimize risk and energy. And because of that, they're gonna more often take the choices that are like, it's just delusional because you're trying to avoid something that is gonna happen because you don't wanna do their work, but it ends up costing a lot more because you're gonna put yourself in situations where you're just gonna be consistently dealing with stuff. Also, now I do think that there is an impact here. It is changing, so I do think that is correct the way that I did this. It is changing the position. So it was just because of the baseline there. So the force is not supposed to be cumulative. It's supposed to reset every time. And is repelling here because not really repelling. It's just that the simulation starts at position that is not supposed to because of the forces. Because of the magnitude of the constant of the force. Just kind of not natural to think about. So what I'm gonna do is just change. I'm gonna write down here. Actually, I think I don't need to change anything else. So just because it is working. So the other thing is just add the other stuff. I'm gonna copy from the other one. I'm just gonna change this function here. I'm gonna copy from here. I'm gonna be right back. I was thinking about, maybe I'll talk about this, but I think I finally understand based on fundamental principles. And I was thinking about talking about this, but like, I'm not really sure if it's worth to spend a bunch of time. But maybe at some point it is. So I was gonna do the same thing that I did here, but to explain. Because I just realized what it means to... Yo, thanks for the follow. I realized what it means to, like, the whole self-improvement thing, what is actually happening. Like, when it comes to physics, what learning actually means. And I think that the best analogy is a wheel. So, like, learning is a spiral because it represents the movement of, like, everything on space and time is always changing, which means it's moving. And what that means is that when you're learning, and everything is a cycle, because like this is something that is more intuitive understanding for me, and I'm not like 100% sure because it depends on how we look at it, because any geometry can be perceived as a contained thing, because geometry is always based on the relationship between different reference frames. But I think it makes more intuitive sense to think about self-contained geometry as a cycle or as a sphere. So, and also because of the shape of the planets and stars and stuff like that, and the rotation of everything. So like a circle in 3 dimensions, in 4 dimensions is going to be a spiral. So when you have like self-improvement and learning stuff, it's just a wheel moving through time, which is a spiral. And what is happening is that in the beginning phase of anything, because of the principle of momentum and inertia, which says that everything has the tendency of remaining in the state that it is. So if something is because the movement is always the relationship between two reference frames. Something can only be moving or standing still in relationship to another reference frame. So if something is standing still, it has a tendency to stay in the same place, and if something is moving, it has the tendency to move, and that's inertia. So what happens is that you are like a wheel, and you are on this place, and in the beginning, the force of the weight is very high because you're standing still, so you have no momentum, and the only way to create an acceleration to a certain direction is by having friction. So if you don't have friction, you're not going to move anywhere because there's no resistance towards that, and that's what causes pain. So every time you learn something, it's impossible to not feel pain because the feeling of pain itself is the movement to somewhere else. So pain creates friction here, and this creates the acceleration on the top, and that generates the movement of the wheel, which creates the spiral. So the more you accelerate through this place, the less impact the weight has, which is the weight is your body. So your body is a neural network, and it has the weights and biases of your synapses that are going to make up your current experience of space and time. So if you want to learn things faster, then what you are trying to do is just accelerate the wheel. So, but this can be problematic because if you reach a threshold where your body can't handle the force, which means that you're trying to lift a weight you can't handle because it's too much pain, you're gonna break the wheel, which is gonna paradoxically make you go a lot slower. So. And that's why flow state, I think, is like the optimal amount, because it's the amount that makes you accelerate without breaking the thing. But I think that the relationship is always this. And I do think that is a physical process, because the difference is that instead of going somewhere, you're downloading data into your body. And this is the reason why it can be risky, and not all the time you should be learning things, because that's the purpose of self-awareness, is like redirecting the acceleration, because if you only accelerate through a certain path, it doesn't matter how smart you are going to crash the car, because space and time is not linear. So it always depends. Yeah, I'll be right back. think I'm gonna take a break. Because I put the timer there for. But it's probably better to do this stuff first. So I was gonna ask this to GPT. I should ask based on Godot, I think. Kind of annoying because it's annoying because of like I want to avoid using limits because limits is. I remember I had to do some stuff. I think it was on TripP. Yeah, depending on which OS you are, you like limits. I think is for Linux. So if you're on Windows, you have to use another one. It's kind of annoying. I guess I can use this one and just put minus. Let me try this. Oh, oh, no, it's just for integration. Adjust the max minimum. That should be enough. Delete this stuff. Minimum, maximum. Next one's max. Max. Should be minimum. Like, of course, that learning is a physical process. Okay, when you think about it, it's kind of funny that we like don't think about the things this way, personality and stuff like that. It has to be a physical process because obviously everything is connected. So I'm gonna replace there. As it shows me now. And now it should be based on the geometry. Let me remove this. Fuck. So I'm gonna test like this. If it works, then I think even if it doesn't work, I'm just gonna take a break. Like probably 15 minutes break or whatever. So here, probably the easiest thing to do. Just multiply by might as well. Conversion from units. Oh yeah, it's because of the type. So this can't be. It's an unsigned integer. So I'm just gonna like whatever. Nice, correct. Nice, a floats. Now I wonder if this is gonna be a problem because it looks like it is not complaining. Hmm. Nice. So maybe I do based on the first. I don't want to think about this. That's the problem. I'm just gonna try like this. Because if I put the first node, if I make this based on the first node here, then I'm gonna have to change comparison here. And I don't want to think about this. Yeah, it's complaining about this one. So I'm gonna try to do... I could just use the same one. Yeah. Probably better. Maybe I think I'm probably gonna stop streaming and then I'll do... Because the other thing that I want to do today is to just convert the other... To convert the other solvers, and I think it's gonna be like easier off stream. Just use the two monitors. I'm just gonna because the other ones are also... This spring might be annoying because of the control point in the middle. But I think I can try in the beginning to do just from the source to the target. And just put the edge length instead. So I'm gonna have to create a function probably on the Bezier curve so that I can get the length. I get the length of the curve. And then I just copy. And I'm not sure if I'm gonna leave. I'm gonna try to copy as close as possible in the beginning to have as a baseline. But I'm not really sure if I'm gonna leave it like this. Because it probably, like I said, it's gonna depend on what kind of thing I'm gonna build. So, and I am going to try to implement layouts and other stuff like this. So it's gonna change a lot anyway. I just wanna have like a good baseline. So it doesn't really matter that much if it is like exactly the same as the other one, because it's not exactly what I wanna do, so. So after and now like I do think that it is correct there. So it is, I think it is correct. But after I add all the solvers, then it's gonna be easier to see if it is really correct or not, because it's just gonna be exactly the same. But I do think that it is correct the way that I have there. So once I implement the solvers, then I can continue. The next step is gonna be to finish the GUI element, I think. Then finish the GUI element and then combine the GUI element with the graph. Then once I figure this out, then I think that's... Yeah, I don't think I'm gonna spend time studying GD extension now. I'm probably gonna do that later. So yeah, probably animations. So I have to understand more animations, but I think I'm just gonna, I'm not gonna dive too deep into animations yet. I'm gonna spend, I think, one day going over the source code of animation stuff. So I'm gonna watch a bunch of videos about animation using from the editor, then spend a bunch of time studying the source code for the animation element, or for the animation classes. Then after I do that, then I think I'm gonna go back to studying instruction set architecture and to studying the Python generator. Because then finally I'm gonna have like the points that I stopped there. But with the GUI also I might spend a bunch of time because I have to put it on the side there. Break down each of the game on a high level and know how to approach building its architecture. No, I don't think so. And so it's fucking up. Oh, the size is negative. Hmm. It's probably because of this. I think I'm gonna go over with the debugger on this one. As obviously is something related to the number here. Just gonna for this stuff's probably better to search on the search engine, like what is the smallest or as smallest value that a float can go, and then I just put that value there to make it easier. Because it is an edge case anyway. Like if there is any node that is going to be outside of the, if I put a very large space in the beginning, it's just going to be an edge case anyway, and I already have the error message there. So as long as it's not like, if I put any value there, as long as it's like big enough to have like 99.99% of the cases, should be fine. Yeah, I'm gonna try. So last thing that I'm gonna try is just put a large value, very small and a very large value, just to see if it is working there. Yeah, I do think that should be correct here. Just checking to see. So if any x of the geometry is bigger, it's just gonna reassign the value. And here the other way around. So it should be correct, the check, I think. And this is gonna make sure that the values here are updated. Actually, I can just simplify this as well and just compare the vector. But I'm gonna do like this first. If it works, then I'll do that. Because they overload the operator on vector 3. So just compare the position right away without having to do this stuff here. I still don't understand why they put it like this. It's whatever. I think if it doesn't work, I'm gonna simplify first, and then I'm going to go over with the debugger, but I'm probably gonna stop streaming now and do this off stream. I do think it's working based on all this stuff that I've seen there. Obviously, the other thing to test is to put a bunch of different nodes instead of just two. Because with two, it's not gonna allow me to test the condition for subspaces yet, so... But I think I'm gonna do that after I add all the other solvers. So I'm gonna finish this, add other solvers, then add more nodes to the simulation. Then if everything works, then I'll move on to the GUI. Oh, the other obvious... forgot about this. Like I might have to, before studying everything, so I'm gonna remove this JIT extension here. So here either study Python parser generator, or I'm probably gonna have to implement the layouts first. So I'm gonna have to study the layout algorithms and then implement them. And then I'm gonna do the same logic there that I did on the other one, which is just put a Boolean variable to check whether or not, if it's either on a layout or the simulation. And then you flip between the two on the inside of the update simulation function. So pass everything through a function outside of the update simulation for the bind set solver. Then, so I'm going to stop streaming here, and I'm going to simplify the comparison there and then check, solve this. But I'm pretty sure now that the simulation is actually correct, and I think it's not repelling the nodes. It's just because it's not natural. When like you're thinking about like a simulation like this, you come with the preconceived notion of the like how it would look in real life. But since it's a simulation, there isn't any other forces involved, and that's the thing that is kind of confusing. So I think that the reason why it looks like it is repelling in the beginning when you have a negative value there is because the initial state is supposed to be with the nodes further apart from each other because the gravitational force is not big enough. But maybe I could be wrong about that as well. But I do think that because of the other tests with the other values, like when you put a value greater than 0, then they come closer to each other. And when I put a value on the range, it looks like they don't move. So I do think that this is probably the relationship. But I'm not really sure though. It might be like, because the thing is, it could be correct the way that I'm doing, but it could be wrong on the other one to begin with. And yeah, I do think that the one that I have now is an accurate representation of the other one that I had before. It's like basically the same thing. Because the sign of the gravitational force is just going to change the direction of the vector of the final thing. So it doesn't really matter that much, it's just a detail. But obviously in real life, you're supposed to attract each other. The bodies, like the gravity is supposed to attract. So I do think that... but I'm not really sure. You might be wrong there, actually. But if it is wrong, it is because of the sign. So just the direction of the vector. But I do think that the calculation is correct. So it might be like it's negative. The thing that might be is because like it's negative there because the other value is negative on the other one. So like this one, it starts off with the negative value. I think because this x, dx, dy, and the z are negative values. So like it's a negative value of the position, and that's why the gravitational constant is a negative. So like it cancels out this one. So I think that's the reason why the other one. So I do think that the direction is correct and the force is correct. When I put this like here is starting from the position, from the negative position each frame. And it's not accumulating the forces. So because it starts at a negative position, the gravitational constant is negative, and then it becomes positive, which makes them attract. I think that's what's going on. So I think the calculation that I have there on the other one is correct. And all I have to do now is just update the way that I'm getting the boundaries of the first space to make sure that they are always encapsulating the geometry, so they don't get the error message there. And once I figure this out, I can just copy these other solvers there, and I'm gonna remove. So after I copy the solver here, which is the first one that I'm gonna copy, I'm gonna comment out the forces that I'm setting to 0 there, here, and comment these ones out, and then I'm gonna be able to see. But I'm pretty sure now that I did everything correctly. The main difference between this approach now is the shape of the tree, because I'm using a binary tree, and also the partitioning of the spaces, but I do think it is correct. So after I implement all the solvers and I test with more nodes, if everything is correct, I'm just going to finish doing the GUI, then work on or study animation a little bit, but I'm probably not going to go too deep into it. Then I'm either going to go back to studying the Python's parser generator, or I'm going to study graph layouts and then try to implement the graph layouts so that I have exactly the same stuff that I had here. So when you change to a layout, it turns off the physics and then it puts the graph on the layout. And also I have to implement dragging, but I think dragging is not going to be that hard because On Godot, it's a lot easier to implement. And this is the part that I was thinking about. Like, I have two options. Actually, no. The way that I'm doing is already, because I already have a class that inherits from Mesh Instance 3D, so I don't have to change Mesh Instance 3D behavior. I'm just gonna add a GUI input, I'm gonna add the input function on the graph node 3D, and then on the input function, I just handle the inputs, and is gonna cancel the camera automatically because the camera is implemented on the unhandled inputs. So all I have to do is call accept event after the functionality, and I think that this is gonna be like easier to implement on Godot than it was on the front end here. And I may or may not do this stuff as well here to search the nodes, but I think that this is probably... So after I finish all of this, then I might go back to studying parser or stuff like that. I'm definitely going to go back to this, but I'm not really sure if I'm going to study layout first or... Yeah. So see you next time.